Now let's do some question on projectile. Suppose, let's see this question. A particle moves in a plane xy with constant acceleration a directed along the negative y-axis. The equation of motion is given by y equals to px minus qx square, where p and q are positive constant, and velocity of particle at the origin of coordinate is. See, in case of projectile, this a used to be g. This a used to be g. Alright. And what was the equation of motion? What was the equation of path in case of projectile on a plane surface? See, you had x equals to u cos theta t, and y used to be, I don't remember exactly. Even if I remember, I'll tell you how to get this if you don't remember. And what you need to do is, in order to get equation of projectile in terms of y in terms of equation of path of projectile, what you need to do is you have to eliminate this t. I did it earlier also for you. If you don't remember, you can do it in exam also. You just replace t with x by u cos theta over here. So this is u sin theta, x by u cos theta, and this is g. So we will get it as y equals to x tan theta and 1 by 2 g by 2u square x square. So okay, so if the acceleration is, instead of g, if I take a, then this equation will turn out to be x tan theta. In place of g, I can put here a, sec square theta x square. So if I compare it with this equation, px minus qx square, then this is going to be a p and this is going to be a q. So p is tan theta and q is a sec square theta 2u square. So we got the angle of projection. Angle of projection is given by this, and we'll get the velocity of projection by, we need u basically. So u is what? U is, I can put here, a 1 plus tan square theta is 1 plus p square. 1 plus tan square theta is x square theta 2u square. So u is going to be what? A 1 plus p square 2q under root. That's going to be the velocity of projectile at the origin of coordinate. That is initial velocity of projection. This is called velocity of projection. Alright. So this is how you can do this question. Okay. Let's move to next question. See here this question. Question says, a car accelerating at the rate of 2 meters per second square from the rest from origin is carrying a man at the rear end who has a gun in his hand. The car is always moving along the positive x-axis. At t equal to 4 seconds, man fires from the gun and the bullet hits the bird at t equal to 8 seconds. Man has fired at 4 seconds and bullet hits the bird at 8 seconds. The bird has a position vector 40 I cap plus 80 j cap plus 40 k cap. Find the velocity of projection of the bullet, and you take y-axis in horizontal plane. It's a 3D kind of question. So let's draw, suppose this is your coordinate system. This is the x coordinate, and I have to keep y coordinate, y-axis in horizontal plane. So can I take y in this direction? Can I take y in this direction and z in this direction? Is it possible? Or there is a problem? Can I take coordinate like this, and with this as we have a vehicle? Let's take a vehicle. Say we have this is driver, and we have a man over here. We have a man over here. Okay. So and he's going to fire a bullet. But see, there is one problem in this coordinate system. The problem is not from physics side. The problem is because of convention that we have chosen. See, whenever we label this x-axis, y-axis, z-axis, you must be very careful to use a what we call right-handed coordinate system. See, physics does not say you to use right-handed coordinate system. First of all, I'll tell you what is right-handed coordinate system. Right-handed coordinate system means a coordinate system xyz is said to be right-handed if I put the fingers of our right hand. If you put the fingers of your right hand, in the direction of x and you curl it towards y. Put the fingers of your right hand in the direction of x, 4 fingers of course, and you curl it towards y, then thumb should go in z direction. But in the coordinate system which I have drawn, if I put my fingers of your right hand in direction of x and I curl it towards y, the thumb will go in this direction. If I put my fingers of x in this direction, x direction, and curl these 4 fingers towards y, my thumb will point in negative z direction. This is not right-handed coordinate system. A coordinate system is right-handed only when if you put your fingers in x-axis, curl it towards y-axis, your thumb should point in z direction. Thumb should point in z direction. If you put your fingers, 4 fingers of your right hand in direction of x and curl it towards y-axis, then your thumb should point in z direction, positive z direction. Then only you can call the system to be right-handed. Otherwise, system will be left-handed. So the system which I have drawn is not right-handed. Either I should take my z-axis below, which is not good for your question. So I must take this y-axis inward. If I want to draw the right-handed coordinate system, I must take this inward, y-axis. And now it is nice. If you put your fingers in direction of x-axis and curl it towards y direction, your thumb will go in z direction. Is it not? This is a right-handed coordinate system. See, whole world has come to a consensus to use right-handed coordinate system. We had an option to be right-handed or left-handed, but the whole world has agreed on this convention that we all will be using right-handed coordinate system, so that there is no confusion. The conventions are made to standardize the subject. So this convention has been formulated so that there is no scope of confusion, because if somebody draw y in this direction, some other person draw y in this direction, then they cannot discuss. Their things will differ a bit in mathematics. Physics does not confine you to right-handed or left-handed. Convention, we have a convention of using right-handed coordinate system, so we go for right-handed coordinate system, right? Okay, fine. So we have this x-axis, y-axis, xy plane forms a horizontal plane and z-axis is in vertical direction. This is a plane, horizontal plane, and z-axis is perpendicular to that horizontal plane. Fine. So we have to find velocity of projection of the bullet. Suppose velocity of projection of the bullet is say Vx I cap, Vy j cap, and Vz k cap. This is the position vector of bird, or 40, 80, 40 is the coordinate of the bird. 40, 80, 40, this is the coordinate of the bird, where the bullet has to go, where the bullet has to go. Okay, so at 4 second, man fires a bullet, and man is holding the gun, and man is on the vehicle, man is on the car, so man is going to inherit all the velocity of the car. Man is going to inherit all the velocity of the car. So gun will also inherit all the velocity of car, and hence bullet will also inherit all the velocity of car. Bullet is also going to inherit, this is the velocity of projection, then actual velocity of bullet with respect to observer on the ground will be this, plus velocity of the car, and velocity of the car at 4 seconds is how much? Or what I can do is, instead of doing all these things, we can say, suppose this is the net velocity of the bullet at t equal to 0, the net velocity of the bullet at t equals to not 0, of course, t equal to 4 seconds. Suppose at 4 seconds man is firing the bullet, so means the original velocity of bullet plus velocity of the car which is superimposed, all these are giving you this velocity, net velocity. Okay, so where is the car at 4 seconds? At 4 seconds your car is at, the coordinate of car is your 1 by 2 initial velocity of the car is 0, I am assuming. So 1 by 2 into a is 2 into 4 in 4 square, that is 16. So it is 16 meter, you can say. So car is lying at 1600, suppose. So bullet is also lying at the same point at t equal to 0. This is the coordinate of bullet at 4 seconds. So not at t equal to 0, at 4 seconds, and we want that at t equal to 8 seconds coordinate of bullet should be what? 40, 80 and 40, right? So t equal to 4 seconds, bullet is here, and at t equal to 8 seconds bullet must be at this coordinate, and the velocity of projection at t equal to 4 seconds is this. It means what? Your see, and there is acceleration of the bullet only in z direction. There is no acceleration in x direction, y direction. So Vx and Vy is going to remain constant. See, xy plane is horizontal plane, so there is no acceleration in x direction, y direction. So velocity of bullet in x and y direction will be same as Vx and Vy. So at 4 seconds you have x component Vx, y component Vy, right? So it should be, the equation should be 16 plus Vxt. Vxt means the distance traveled in x direction by the bullet will be 8 minus 4 into Vx, and 16 is the initial position of bullet on x axis. So that should give me what? That should give me 40. Are you getting a point? See, in general what I can say is your V is Vxi, Vx will remain same at time t, and this is going to be Vz minus, so this is the velocity of projection. So as the time passes on, your Vx will not change, Vy will not change, but Vz is going to change. Vz is going to change, right? And as the time passes on, so your we want x, this is initial x is 16 and final x has to be 40. So the equation will turn out to be 16 plus Vxt is 40, right? And time taken by bullet to reach the target is how much? It started 4 seconds and hit the target at 8 seconds. We have 4 seconds. So Vx into 4 is 40. So Vx is how much? 40 minus 16 is 24. 6 meter per second. Similarly, the y coordinate of the bullet at t equal to 4 seconds is 0. And as the time passes on, y coordinate increases at the rate of Vy, and it must reach at t at 8 seconds. At 4 seconds y coordinate is 0, and at 8 seconds it should be 80. So time taken by Vy, time taken by the bullet to reach y coordinate 80 from 0 is 4 seconds. So Vy is what? 20 meter per second. Okay. And how the coordinate in z direction is varying? Coordinate z direction was 0 at t equal to 4, and it should vary like this, and that should give you what? 40 after 4 seconds. So that is Vz into 4 is 40, or Vz should be how much? This is 80, and this is 120 by 4, so that is 30. So Vz is 30 meter per second. So your velocity of projection is Vx is 6 meter per second, Vy is 20, and Vz is 30 kcal. Okay. Look at this question. The velocity of a projectile when it is at greatest height is 2 by 5 under root times velocity when it is at half of its greatest height. Determine the angle of projection. See, we have the formula at the greatest height. H max, your Vy is 0. So V is same as Vx, and if U is the velocity of projection and theta is the angle of projection, then velocity is U cos theta. And when it is at half of its greatest height, see, greatest height is how much? U square sin square theta upon 2g. Alright, so let's find out. See, your Vx every time is V cos theta, but Vy keeps on changing. Vy deaccelerates. So we have taken a U, so I write U cos theta, and Vy keeps on changing. There is an acceleration of minus g in y direction. So this is what we have for Vy. So we can say that Vy final square equals to Vy initial square minus 2gh. That's the formula that we have been using in motion in one dimension for uniformly accelerated motion. So acceleration is minus g, so we can use this formula. So Vy final whole square, Vy initial is what? Vy initial is U sin theta, so it will be U square sin square theta minus 2g, and this is H max. So I want the Vy at half of H max. I want the value of Vy at half of H max. So half of H max is 1 by 2 of U square sin square theta upon 2g. So 2g will cancel out over here, and what is left is U square sin square theta 1 by 2 U square sin square theta. I say 1 by 2. So Vy at this half of H max is 1 by 2, 1 by root 2 you can say, U sin theta, and Vx always remains same, that is U cos theta. So velocity is going to be Vx square, so that comes out as u square and 1 by 2 u square sine square theta, which is root 3 by 2 u. We can write like this, u. Oh no, sorry, this is v, this is sine square theta cos square theta. We can't do anything. Okay, so that's the velocity at half of the greatest height. It says the velocity of projectile when at the greatest height, velocity of projectile at the greatest height is u cos theta is root 2 by 5 of velocity at half of the greatest height. That is, velocity at the half of the greatest height is going to be, you can take u outside, this will be cos square theta and 1 by 2, so this u will cancel out, and if I square both sides, this will be 5 by 2 cos square theta 1 by 2 sine square theta, or I can say this will be 3 by 2 cos square theta, or tan theta is root 3. Alright, so theta is 60 degree. Theta will be 60 degree. Alright, okay, let's move to next question. The question says a particle is thrown on a triangle from one end of the horizontal base, and after grazing the vertex falls on the other end of the base. If alpha and beta are the base angles, theta is the angle of projection. Prove that tan theta is tan alpha plus tan beta. Let's draw the figure first. This is a projectile. This is the projectile, and this is triangle. Let's call it O. This is the x-axis. This is y-axis, and say this is the velocity of projection. This is the angle of projection theta. This angle is alpha. This angle is beta. All right. So suppose the range of projectile is r. R is the range of projectile, and the height of this triangle, suppose this is h. So if this is O, this is P, and suppose this is A, so the range will be OP, which will equal to OA plus AP, and OA can be written as what? See this triangle, H, what we can write? H cot alpha, and this is AP is H cot beta. Instead of this, what I can do is, let's consider this coordinate to be x comma y. Let's consider this coordinate of this vertex as x comma y. So x comma y lie over here. So I can write this tan alpha and tan beta in terms of x comma y. So what is tan alpha? Tan alpha is going to be, this is what? This is now y. So it is y upon x. This is going to be x then, and this is going to be r minus x. And tan beta is what? Y upon r minus x, where r is the range. I the range. And what is the trajectory, equation of trajectory of the projectile motion? That is y equals to x tan theta, and then you have gx square upon 2u square sec square theta. So xy is going to satisfy this equation, x and y is going to satisfy this equation. This can be further written if we make use of this range. See, what is range? Range is u square sin theta cos theta upon g. See, if I introduce range over here, this is gx square, and 2u square, in place of 2u square, what I can write is r into g. If I take g on this side, and this is cos square theta, and then you have sin theta cos theta. I have expressed this u square, 2u square, I am writing it as 2u square written as rg upon this. Alright, so this will come as what? X tan theta, g will cancel out, this will be, so this is going to be x square tan theta upon r, or I can take x tan theta common, so that is 1 minus x by r. So this is going to satisfy this equation, y equals to x tan theta 1 minus x by r. So what is tan theta? Tan theta is going to be yr, and from here tan alpha plus tan beta is y by x, so that comes to be, as will be written as yes, so yr minus yx plus xy, this will cancel out, and this is same as tan theta. So tan alpha plus tan beta is tan theta. Okay, so this is how we can proceed, right? So this is proved, this thing is proved, and this is very important relation. This is very important relation which we have.